Hello everyone, my name is Zeshan Shoaib and today I will give you a brief introduction of fNIRS neuroimaging device. These are the contents of my today's presentation. So firstly, I will talk about the theoretical introduction of fNIRS system, and then I will give you a brief introduction of instrumentation of this device, and after that I will talk about the advantages and disadvantages of fNIRS system. After that, I will try to show you the comparison of fNIRS with other neuroimaging modalities, mean where this device stands in neuroimaging devices. And in the end, I will talk about the data preprocessing and data analysis. So let's start the presentation. So in theoretical introduction, firstly, we will talk about what near infrared spectroscopy is. So near infrared spectroscopy is an emerging non-invasive monitoring modality based on chromophore absorption of infrared light. It provides a real-time continuous measurement of regional cerebral blood oxygenation and indirect blood flow. The light used in near infrared spectroscopy is the light spectrum between 700 nanometer to 900 nanometer, and this lies between very near to visual wavelengths of the light. As I mentioned, the concentration changes of oxygenated and deoxygenated hemoglobin are calculated by NIRS devices, and this is possible because these chromophores absorb light in NIRS spectrum. As we can see in this figure, in our blood there are many chromophores, but three chromophores are the main absorbers of NIRS light, uh, and those chromophores are oxyhemoglobin, deoxyhemoglobin, and water. And in the optical window from 700 to 900 nanometer, you can see that all these three chromophores have different light absorption spectrum, and we use this optical window in NIRS system because less than 700 nanometer the main absorber is the biological tissue, and greater than 900 nanometer the main absorber is water. And all this information we can also see in this diagram. And mostly the NIRS devices used wavelengths from two different wavelengths, 760 nanometer and 850 nanometers. And these wavelengths, they are used because these wavelengths gave the best resolution of the values of oxy and deoxy concentration changes separately. The basic concept of NIRS is when we do some activity, it is well known fact that the brain requires more oxygen in comparison to rest state. Using the NIRS light source, we can shoot the light on the scalp and can detect the light at the other end after passing through the brain tissues. So as we see, some of the light will scatter and absorb by the brain tissues, and some can detect by the detectors at the detector's end. Here we can see the complex brain activity steps involved in measurement of optical densities due to brain activity. After recording the neural activity, we apply the modified Beer-Lambert law to convert these optical densities into the oxy and deoxyhemoglobin concentration changes. This is the overall setup of fNIRS system. It can be divided into three parts. First one is the CPU, second one is the NIRS device, and the third one is the screen to show the neuromodulation recordings. The NIRS system has sources and detectors to record the brain activity. These source and detectors are connected with uh, NIRS device by fiber optic wires. These wires are very delicate, so the user should be very careful to use them. If the user shows some carelessness, uh, so he can break the wires. Also here we can see the NIRS cap to where the source and detectors on the skull. The researcher carefully choose the opt-out configuration and prepare the cap according to the study design, and after preparing all the instrumentation, the data can be recorded. Here we can see some advantages and disadvantages of NIRS systems. So in regard to quality of data, the advantages are in contrast to other neuroimaging techniques, it has the freedom of movement. It has no motion artifacts while the children are participating in behavioral manipulations that require in talking, writing, and eating. There are automatic algorithms to reject signals that fall outside the range of hemodynamic response. It allows us to test infants in a state of full attention with low task demand. And some disadvantages in this regard are it is limited to measuring only surface cortical activity, means we cannot measure the deep neural activity with this system. The current spatial resolution of optical brain imaging is typically limited to few centimeters, and uh, in the sense of ease of use of this device, the advantages are this technique is quite easy to use. The devices used in this imaging are silent, so the presentation of auditory stimuli is easy. The device is portable and does not require special housing. And some disadvantages in this regard are the development of the data analysis techniques is in its infancy. There is no agreed upon method for data analysis. There is a great deal of variation to getting information regarding to co-registration, and in the operational costs, the advantages are the operational cost is comparatively cheaper over other neuroimaging devices, but the only disadvantages in this regard is the fiber optic cables can break over time if they are not handled with care. In this diagram, we can see the comparison of NIRS system with other neuroimaging modalities. Here we can see that this device has advantages over other modalities in different aspects. It has a better spatial resolution uh, than EG and MEG. Also, it has better temporal resolution in comparison to fMRI and PET. And if we see the degree of immobility, its mobility is also good as compared to PET and fMRI. So this means that fNIRS could be a most favorable device, neuroimaging device in future. Here we can see the different steps from experimental design to statistical data analysis. We already talked about experimentation and data acquisition. Now we will talk about pre-processing of the acquired data. In pre-processing, we have mainly four steps. Intensity to optical density conversion, um, which we got done in the machine already and got the data from machine in optical densities. After that, we can convert optical densities to concentration changes by modified Beer-Lambert law, which we already discussed in previous slides. And after converting the data into concentration changes, we can correct the motion artifacts and filter the data to get the pure activity of the brain. Here we can see different types of artifacts and their frequencies, which can be found in the NIRS data and can be removed by filtering. Here we can see the motion artifacts and these motion artifacts also can be corrected by different methods, and from which principal component analysis is the most commonly used method to remove the motion artifacts. Here we can see the examples of motion artifacts. Means if in the NIRS data, if you see these type of shifts are very high peaks, so these can be considered as the motion artifacts and can be removed by applying the principal component analysis. Here we can see some artifacts removal techniques which researchers mostly use to remove the artifacts. First one is the frequency filtering, and this is the really commonly used technique to remove the machine drift and physiological noise. Physiological noises like respiration and cardiac artifacts, and the principal component analysis can be used to remove motion artifacts. And there are also some other filtering techniques like adaptive filtering, Kalman filtering. The detail of these filtering techniques can be found in these links, uh, and these links are also mentioned in the description of this video. Here in this link you can find some uh, pre-processing MATLAB codes to practice the data pre-processing, and this link is also mentioned in the description of this video. And by downloading the MATLAB codes from this link, it will be very good for the beginners. If you want to learn data pre-processing or data analysis of NIRS data, you can download the MATLAB codes and you can learn and practice easily from these codes. After pre-processing, the last step is the statistical data analysis. Here are some data analysis techniques. The first one is the general linear model, GLM. There are many softwares to apply this technique on the NIRS data, like Nurse Lab, Nurse SPM, Nurse Analyzer, Brainstorm, and many more. You can install these apps and can use GLM to uh, analyze the data. Also, there are some statistical techniques to analyze the data, like Pearson correlation, ANOVA, robust correlation, phase synchronization, wavelet transform coherence. Uh, so today I will not go in deep to these statistical analysis techniques. If you want to uh, find some detail of these statistical techniques, uh, here I mentioned this link. You can find the detail of some of uh, the statistical techniques from this link. I also mentioned this link in the video's description. So this is the end of today's presentation. If you have any question or comments, please mention in the comment section of this video. And thank you for listening me, and have a very good day.